Because I'm sharing the code of this program with you at this point, I decided to make a video that just quickly goes over what the code does so that as you scroll through it, you have a guide that will just kind of tell you what each part of it does in case I went too quickly in one of the previous videos. It just will allow you to put this code in context, and it might actually help you to understand some of the code as it's written. Before I made this video, I decided to rearrange where some things were in this program to make them a little better organized and easier to explain. So the code that I'm sharing with you is this new updated version of the program that I think is a little bit more clear. I haven't made any major changes, but I've just rearranged things. Okay. I did fix one bug, which I'll talk about in a second. All right, first, before we look at the code, let's just remind ourselves what are the features of this program right now. So let me just stop it right here. So the features are, it draws a border, which currently is a little bit larger than the screen space that we have here. Well, let me give it a little bit more space for the moment. Okay, so that we can see the whole thing. All right, and so we've got two sprites that we can see. And one of them is the snake head that's a square, and one of them is the food that is a round orange circle. So the snake head will move to the right, and when it collides with the wall, it will stop. And it actually stops the program at that point. That's currently how the snake behaves if you don't do anything. The snake head, though, will move if you hit the arrow keys. And the 4 arrow keys in this program are active, and it's listening to the arrow keys, but it will not reverse direction if I use the arrow key that is in the reverse of the direction the snake is moving. So that's another feature of this program. I think this is the final feature of this program is that when the snake collides with the food, it moves. And that will only be significant once because the food always moves to the same spot right now in this program. It doesn't move to a different spot. I think that's everything. Obviously, it also draws the borders. I don't know if I mentioned that. Okay, so now let's take a look at the code. Since we've gone over what the code does, let's look at how it does it. So I'm going to suggest to you, so we're looking at the code over here on the left, but what I'm going to suggest to you is that sometimes it makes sense to start looking at the code, not just at the top and going down, but sometimes it makes sense to look at the code starting with the main part of the program. And it's going to depend on how the programmer has organized the code. The better the programmer has organized the code and put in comments, the easier it will be to understand how this code works. So usually in most of the programming languages that I'm familiar with and dictated by good programming practice, a file that has functions and other code in it usually has the functions up at the top of the program, and it may also have variable initialization near the top of the program, and then the main part of the code will be near the bottom, which means, and this may seem odd to you if you're new to programming, it means that it's sometimes easier to understand what a program is doing by going to the main part of the program near the bottom first, and then looking back up at the functions to see what they do. So in other words, you're looking at what uses the functions before you look at the functions. And that's another reason that it's important to name your functions something meaningful, because it will actually help you understand what the functions are doing before you even see the code for the functions. All right, so just to go over what we import here, import turtle means we are using the turtle library. And one of the things the turtle library gives us is it gives us a generic turtle object that can be used to draw things on the screen. So let's scroll down to the comment where I indicate that it is the main part of our program. Okay, here's the main part of our program, and here's what we do. After all of the function definitions are done, what we do is the program runs. So the first thing that happens in the program is we set up the sprites. I have recently moved the sprite setup to the main part of our program because it's part of the important beginning section of our program. We create the head sprite and we create the food sprite. I found a syntax error when I was going through my code that when I copied and pasted the head, setting the speed of the head sprite, and I pasted it into the area of the food sprite, I forgot to change it so that it was the food speed set to 0, which caused my food movement to be very slow. And fixing this actually fixed my food movement speed. So anyway, in this section, we are setting up the head by changing its color and shape, and we're doing something similar for the food. We create these two sprites, and then we set them up. And the location is part of that setup. We're also initializing the score variable because we're going to keep track of the score. And then we get the screen object from the generic turtle that the turtle library gave us. And that allows us to set the background color of our turtle area to a honeydew color. Then we draw the borders by calling the draw borders function. Let's jump up to the draw borders function and see what that does. So what the draw borders function does is it uses our generic turtle object to move around the screen and draw a square that is the borders of our play area. These are all straightforward turtle commands that if you've used the turtles you're familiar with. So I'm going to skip over explaining those and go back to the main part of our program. So that's what calling draw borders does for us. I'm going to note that we could have just put all those commands here right in the main part of our program. We don't need a function for this, except that it makes our code a lot cleaner and clearer. I don't have to go back and check draw borders because once I know that it's drawing the borders, this call tells me that all that movement of the turtle draws the borders. And that's how functions can help make your code easier to read sometimes if they're named properly. Next, we are going to send some commands to the screen object because that screen object is what manages our ability to listen to keys on the keyboard. So this is what gives us the ability to do user input in real time in our game. So this is just part of how keyboard listening works. You have to tell the screen to listen to keyboard events, and then you have to set up specific events by associating a key. So the name of the keyboard key goes here with a function that you've written. And that function name goes here. So what this is telling us is that we must have 5 functions, one called go up, one called go left, one called go down, and one called go right. And then a function called so done. And these functions are triggered or called when we hit the up key, the left key, the down key, the right key, and then also the X key. Let's take a quick look at those 5 functions. Go up, go left, go down, and go right. Here they are. That's not where they are. Here they are. Go left, go right, go up, and go down. And it seems like what they do is they change. Each of them is going to check whether the snakehead's behavior is a certain thing. And if it is not that thing, then it is going to change the snakehead's behavior. So, for instance, go left is going to set the snakehead's behavior to left if we're not already going right. So we're going to assume that somewhere in this program we're using that behavior, but this is what sets that behavior so that the snakehead knows what its current behavior is supposed to be. One way to describe this is it's changing the state of the snakehead. It's changing the state by setting its behavior to left. And each one of these other routines does the same kind of thing, but with a different direction. And then there was there's another separate function here that is called so done. It's not a great name for that function. I should probably rename it. But this is setting a different value. It's setting the turtle. The generic turtle has a variable associated with it called done, and it's setting that to true. Okay, we don't know what that's for yet, so we're going to keep reading what the main part of the program does. Okay, so that was taking a look at what these key responses to key presses are. One way to describe this function is that's a handler. It's an event handler. Pressing a key is considered to be an event in a program. And for this event of pressing the up key, we have a handler, which is a function that handles the event. Once we have detected something has happened, we have an event handler to handle that event. Okay. So this is our first reference in the main program to turtle.done. We are setting turtle.done to false, and we just saw that when the user hits the X key, that is what's going to change turtle.done to true. So now we know two things that are happening. We're starting out with turtle.done being false, and then eventually, if the user hits the X key, it's going to be set to true. And now we're setting the starting behavior of the snakehead to go to the right. And that's actually what we saw when we ran the program. The starting behavior of the snake key was to set it to go to the right. So we should have a comment here. And call this the main game loop, because this is where the animation action happens in our program. And so what we're doing is we have a loop that is going to continue while turtle.done is false. So while not done, we're going to repeat this loop. Now we see why turtle.done is set to true when we hit the X key, because once done is true, once we are done, then this loop will stop happening. But as long as turtle.done is false, as long as we are not done, this loop will continue. If head.behave is up, so if the behavior of the snakehead is up, then we call a function that does the animation for one tick of the clock for that behavior. And that's what's happening with each of these. We're checking the behavior of the snakehead, and based on whatever the current behavior is, we're doing an animation that steps it in that direction. Let's go and look at those routines now. So those functions, step right, step up, step down, and step left, they set the heading to be the correct direction, and then they move the snake a little bit in that direction. That's what they all do. So these are the snakehead behaviors. Okay, we're almost through with the main game loop. So another thing that happens in the game loop is we check whether the snake has collided with the wall. And now we see that by the snake colliding with the wall, this is one of the ways turtle.done can become true. And when turtle.done becomes true, we know the loop is going to end. So that's one way for the game loop to end. And then the final check within our game loop, the final if statement, it checks whether the snake ate the food. And if the snake ate the food, we increase the score. We print the score, so we've got a debug print here. And then we move the food. So there are two things we're doing here. Actually, I glossed over the collision with the wall function. Let me go back to that quickly. If the collision with the wall happens, turtle.done is set to true, but we've hidden how we check whether we collide with the wall in a routine. So let's look. Collision with the wall is a function that will return true if we've detected any of these conditions, which is if the x coordinate of the snakehead has exceeded or gone below the extents of the play area. So in other words, if the direction in x has gone over 200 or equal to 200, or if it's below or equal to negative 200, or if the y direction, if it's gone up higher than 199, or really higher than or equal to 200, or below or equal to negative 200, then it's going to say return collided. Tell the main part of the program that you've collided with the wall. And that's how collision with wall works. So snake ate food. How do we check whether the snake ate the food? So let's check on that. So snake ate the food. First of all, we set 8 to false because we assume that it hasn't eaten the food. And then we check if head.distance, if the distance between the head and the food is less than 15 units, screen units, those are probably pixels. Then we set 8 to true, and then we return 8 to whoever called this function. Okay, so now when we look down here, we can see that what this is doing is if the snake gets within 15 units of the food, we're going to say, yes, the snake ate the food. So that's when we're going to increase the score. And that's when we're going to print this score to the screen just because we wanted to see whether it was increasing. And then we're also going to move the food. And what does move food do? So we go back up to the behaviors part of the function definitions. The food behavior, move food, will hide the turtle, the food sprite. It will move. It will go to 50.-100, so it will send the food to 50.50 and -100, and then it will show the food again. And that's how that works. And that's the last thing it does in the while loop. It will keep doing these things. It will keep doing these checks. It will keep animating the snake head until turtle.done becomes true, and then this loop will end. And when that loop ends, it frees it to do these two print statements. Game over, you hit the border, and it just prints a done message, and then the program is over. So now we know actually that we should change this, because it used to be that the only way to end the game was by hitting the wall, but now, well, actually, there are two ways that this game ends. It ends if we hit the wall, but it also can end if we hit X. So it's not accurate to say that we've hit the wall. If we wanted to notify the student, the player that you've hit the wall, we'd probably put a print statement here. That you hit the wall. And now that's in the right place. And that's what this program does, and that's how it does it. And I hope this overview has been helpful to you.